Maybe in a minute we can start.
The screen is visible, but you have shared.
Yes, ma'am. I guess that my screen is visible and I'm audible to all of you.
Hello, Aditya Nigam sir.
Yes. Yes, ma'am.
Hello.
Yes, I can listen. Hello, all of you can listen to me? Yes. Okay. And my screen is also visible to all of you. Yes. Okay. Good. Okay. Thank you. Yeah, so screen is visible and I'm also audible. And now we have got 69 participants, 70. So I assume that you all are got connected. PPT is not visible. Yes, PPT is not visible because it's right now showing my screen. PPT will be visible soon. You can see my screen. My screen is being shared and you can see my screen. Yes. So this is the, so now you can see my screen, right? You all can see my screen. Yes. Yes, Prachi Bhatnagar. Yes. Okay, let
Hello,
us
sir.
start. Yes.
Am I audible to others?
Yes, you are audible to others.
Sir is not able to. Hello,
No, no,
sir.
I am able to. Yes, I am able to listen as well. I'm also audible to others as well. I'm not sure that whether, because others are able to listen to me as well as they are able to see my screen as well. Yes, Smriti Upadhyay is writing this. That can any one of you write that Aditya Nigam is visible as well as screen is shared? I cannot right now write because I'm using the stylus. Yes, audible as well as screen is visible. Yes. Okay, visible and yes, sir, both. Fine, good. Let me start. Okay. Yes. So what we are going to do is that suppose that this is some 3D scene that is in front of you. You have got some 3D scene in front of you that you wanted to capture, and you are capturing it using a camera. So camera is
Sir, you are
over
not
here.
audible. Hello.
Can anyone write because she is not able to see? We are
Sir is speaking. No, we are not able to hear.
your speakers are actually probably creating some issue. Let me in call messages. Aditya Nigam is visible and audible. Please see this. I am visible and audible. Katie is also have written audible. This is done. You may have sound issues. Uma Medi Uma Madam may have some issue in connection. Okay, so let me start. Okay, right. So I'm having some scene. I'm having a camera, and given this camera, I want to capture this scene. So depending upon the range that my camera can see, this whole thing actually is being this 3D thing is actually being converted into a 2D image. Right. So this 2D image is now capital I. So this can actually be seen as a function. 2D image can actually be seen as a function in which you just give me. So first of all, see that this 2D image can actually be first of all seen as a matrix. What's a matrix is? Matrix is that I am having a rows and column. How many? 100 rows and 100 columns. This is not 11. This is 1 comma 1. First row and first column. That is why it is 1 1. This is not 12. This is first row, second column, first row, third column, first row, fourth column, first row, 100 column. Then second row and 100th column. Then third row, first column. 100 row, first column. 100 row, 100 column. And if I say that take any pixel which is here, which is I comma j. So this any pixel which is I comma j is being written as I comma j for this capital I image, and this is nothing but the ith row and jth pixel. Basically ith rows jth pixel or ith rows jth column. This is I jth pixel. Let us see. Is this clear to everyone? There is the basic image structure. Simple two-dimensional matrix. Basic image structure. Yes. Sudeshna Pradhan, she said in call messages someone is calling.
Sir, Aditya sir.
Yes.
Sir, at the end, we are supposed to give the PPT to the audience.
Okay.
So, how do you plan to share the content with them, sir? In the form of Microsoft PPT or because
This
I'm
same thing because nothing in Microsoft I do not have with this. I can share this stuff, whatever I
entire,
have covered.
okay, entire board? What is this board?
Yes, entire board I'll give.
Contents. Okay, thank you.
Yes. Okay. Okay. Entire board. Yes, entire board I can give. Okay. So this is now the I comma jth pixel. Now the point is that this is the whole dynamics of an image in which we are having ith row and jth column. Now suppose that the image that you captured is something like this, completely blank, black image. Nothing is important. Where you are looking, if I say that if I give you I1 image like this, where you are looking, you don't know. Each and every pixel, whatever you are seeing, they all are black. So everything is same, equivalent, and not much different. Everything is okay for you. Nothing much important. Now let us see this I2 image. This whole thing is white and this whole thing is black. If I take this pixel or this, both of them are equally important or not important. Whatever their importance is, they are same. If I give you this pixel, this or this or this, all of them are having same amount of importance. Now over I2, if I say that do you feel that there are some pixels which are better or more important, or if I show you an image like this, where you are looking. If I show you a image like this, if I show you an image like this, where you are looking? Let us see what others are saying. Where we are looking in call. Right. Light points on the line. Yes. So which line? Let us see. So you must be interested in these pixels. Why you are interested here? Yes. Why we are interested over here? This is correct that now every pixel is not exactly same or having equal importance, but few are having more importance. Why? Why you are interested over, let me write, why you are interested over pixel number 1, pixel number 2, pixel number 3, these pixels. What's the reason behind this? Let us ask. Boundary. I'm very thankful to all of you that all of you are answering perfectly correct, and you all are, I assume, that understanding well. Yes. Now, boundary. Who is creating this boundary? How you can detect a boundary? Let us write it over here. Boundary. How I can come up with a boundary? Who can give you a boundary? Can anyone tell that how I can get boundaries? Vishnu Chakravarti is exactly correct. Sudeshna madam was also correct that there are points on the line. Why it's a line? Because there is a boundary. How can I find out where is the boundary? How can I get where is the boundary? You have to tell. Coordinate of the boundary, yes, but how can I get that this point is actually a boundary? M minus n minus 1 for the matrix, yes, but that is the boundary of the image. Jasila, madam, see this, that this is the boundary you are talking about, but we are talking about the boundary which is there in the image here. We are talking about this boundary. How can I get a boundary over here? Who is going to give me this boundary? How can I get the boundary? First of all, let us know that how can we get a boundary? The value is the range between 0 and 1, yes. So values are ranging between 0 and 1, which essentially mean that all those which are here, they are 1, and all those which are here, they are 0. So how can I get the boundary? You have to tell. You all are moving in the perfectly correct direction. Mid position of what? Mid position is why it is mid, because I have made it in this way that this boundary is in the middle. Suppose that I'm having my image like this, and right now these many pixels are white and these pixels are black. Now the boundary is over here. How can I get this boundary? It's not always in the middle. It is in the middle because I have made it in the middle. Color change pattern. How can I get this color change pattern? Color difference, yes. Clarity, yes. But how can I get this color? And Rani madam has written it that the color differences. Some Yogini madam has written color change patterns. Yes, how can change? How can we find out differences? You all are going in the correct direction. How can I get differences? How can I get the changes? Value of the pixel change. Yes, change. How can you get the change? Majority is not going to work because majority is going to tell you resolution of the pixel is also not correct. Change and differences is something. How can I get the change? 0 to 255 is fine, but how? Yeah, comparison, fine. How can I do comparison between two pixels? Yes, 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 yes. Thresholding is also correct. Hue saturation is also fine. Let us write what you all have written. Yes, differences. How can I find out differences or changes? You know that these pixels are those pixels where we are feeling some variation. Variation in variation in intensity or color with respect to a neighborhood. And what is that neighborhood? That neighborhood is in x direction. Can you see that? That in x direction, which is this, in this direction, if I wanted to know that whether it is important or not, I will take one pixel to its left and one pixel to its right and compare their values. How can I compare? So you just subtract their value and see that whether it is more than 0 or less than 0 or more than a threshold or less than a threshold. So always differences, changes, they are being computed using very simple thing that we used to call it as derivative. You just have to differentiate. If I give you an image, how can you differentiate an image? I will go to each and every pixel and ask one question. Is there any difference to your left and to your right? Is there any difference in intensity when I compare your left pixel and your right pixel? That is your first order derivative. You all remember first, what is my first order derivative? If I give you that first order derivative is f of, let us write, f of x plus h minus f of x divided by h, limit h tending to 0, and when my h is equal to 1, what does it become? It becomes f of x plus 1 minus f of x. It is just a finite differencing. So if I wanted to ask every pixel one question, that are you important? Do you have any change? What I should have to do at each pixel, I will go here and I will say that what is your left, what is your right, and subtract and see that whether it is more than threshold or less than threshold. What you are going to get for this pixel? 0. What you are going to get for this pixel? 0. What you are going to get for this pixel? 0. Why? Because to the left it is 1, to the right it is 1. So there is no differencing, there is no change for all these pixels. Similarly, if I'm here, if I do go here and here, one pixel left, one pixel right, no change. If I'm here, one pixel left, one pixel right, no change. But I'm here, one pixel left, one pixel right, I'm getting change. That is derivative. Let us see, do we understand the meaning of this derivative and how we can get? Noting the differences, that is correct. You understand that how we can find out the derivative? You can write in the chat box. Noting the differences is correct, and we need to find out that how, whether they are actually a part of this difference or not. There is some difference to its left or to its right or not. How can I do that? At each pixel I will go and check that what is your left neighbor, what is your right neighbor, and then subtract it and see that whether it is more than a threshold, less than a threshold. That is going to tell that whether that pixel is having some difference or not. Is this clear to everyone? Because that is the, yes, that is the basic image processing operation. Yes, good, good. Aparna, Perla, oh yes, all of you, very good, that's fine, very good. So how can I do that? So that is, I am going to show you one by one. But before that, if I show you another image like this, where are you interested? You may be interested on these pixels. So similarly, why these pixels are important? Why these pixels are important? Because these pixels are also not one pixel long, by the way. So then you will see that I take this pixel, subtract from here to here, then there is no difference. No, these pixels are not one pixel long. They are, because whatever the fine line that you draw, mostly one pixel long images, one pixel long edges are not there. One simple edge can be actually like this, which is having multiple pixels in between. So you may be interested where? You may be interested here, sorry. You may be interested over here. You may be interested over here. So one edge is going to tell you the left edge boundary and the right edge boundary. So you are interested in what type of pixels? So if I show you an image like this, you may be interested in these pixels. Or if I show you image like this, you may be interested in pixels like this. Now the question is that why these pixels are important? Because they are going to show some structure in your image, and that spatial relationship and that structure is the thing in which we all are interested to extract, because that is going to tell you that whether in that image there is 7 or there is 1 or there is 0. So whatever is written in the image, lower level, there are edges like this. There are going to be some edges, and if we can somehow find out these edges, we can add these edges, that if I get an edge like this and a edge like this, then this is 7. If I get an edge like this and edge like this and edge like this, three different types of edges, their combination is going to tell me that whether it is 1 or not. So when you wanted to do any sort of recognition, we need to understand how we can figure out whether how and different types of edges are there, how many types of edges are there, and how these edges are combined and related to each other, which essentially mean that how do we know what pixels are important and how much. So basically we can use differencing or changes in x direction like this, or maybe sometimes in y direction, because if you are having edges like this, then in this there is some x direction variation is happening, and if you have an edge like this, then you need to check the need to check the neighborhood or the variation in this direction. Okay, now what type of questions we need to ask to each and every pixel? The question that we need to ask to each and every pixel is that do you have an edge like this or this or this or this? Why? Because these are some fundamental edges. These are vertical edges, these are horizontal edges, these are diagonal edges. And maybe using these type of edges, we can combine these edges in such a way so that we can look for all possible edges that can be there in the image. How I can ask question like this to each and every pixel? And that is why we require convolutions. The answer is convolutional neural networks, and the answer is that first we need to understand convolution can be used to answer such questions. So if you need to ask a question and that question need to be asked to each and every pixel, then um, then we need to use convolution. What is this convolution? That is the thing I am going to show you so soon probably, and it's very simple operation. We need to just see that suppose that I am having my image, and that is I11, I12, I13, I14, and I15, I21, I22, 23, 24, 25, 31, 32, 33, 34, and 35, I41, 42, 43, 44, and 45. And this I55, sorry, I 51, 52, 53, 54, and 55. Now this is my image. What is its size? 5 by 5. Okay. I am having a small question which is being, and my question is actually incorporated or embedded in this kernel. What is the size of this kernel? 3 by 3. That is my question. And I wanted to know that minus 1, minus 1, minus 1, 1, 1, and 1, and 0, and 0, and 0. Now, this is a very specific question. I will show you one by one what is the meaning of such a question. But first of all, see that I wanted to know to each and every pixel that, hey pixel, can you tell me that do you have a pattern like this? What is this pattern? This is trying to see that I am trying to see that there is a very specific pattern. What is that pattern? I am going to show it to you. Now suppose that I take this, place it over here. Now you can see that who is my central pixel. I am asking this question to whom? Right now I wanted to ask this question to this guy. What is this? I33. Over that I wanted to ask a question. I will take this kernel. I will take this kernel, place it over here. When I take this kernel and place it over here, this means what? And what we are going to do is, let me write using some other pen. Right. So what we are going to do is for I33, I am asking a question, and this question is embedded in this filter, And what is this going to happen is that this multiplied by this. Why? Because when I take this and place this central pixel aligning with this over here, minus 1 is aligned with this, 0 is aligned with this, 1 is aligned with this, minus 1 is aligned with this 0 is aligned anyways to 3 3, 1 is aligned to 3 4, minus 1 is aligned to 4 2. You all understand that then I am writing minus 1 over here, this got multiplied, this minus 1 got multiplied, and this got multiplied with minus 1. They are going to be multiplied by 0, and this is going to be multiplied by 1. How many? 9 multiplications we have done. 9 multiplications. Let us see. This 9 multiplication is clear to everyone? 9 multiplication is clear to everyone? Voice is again breaking. Yes, 9 multiplication is clear to everyone. Fine. Let us see. This 9 multiplication, I add all of them. I will get one single value. What it is going to be? That single value, that is going to be I22 with a minus sign. So let me write it in a better way. I24 minus I22 plus I34 minus I32 plus I44 minus I42. Can you see that these 9 and how many? Yes, so these 9 multiplications are there. Out of that, 6 are actually become 0. And how many additional terms that you are going to see? This 9 multiplication, 9 values got added up, 6 only are remaining, 3 are becoming 0. And what you have got? Can you see that this is, what is this, what is this, and what is this? That is the differencing in this direction, differencing in x direction. So you have got to know, for with respect to this pixel, that hey, my question was that, hey, do you have some variation in x direction? Do you have a color change in x direction? Do you have difference in x direction? And who to which pixel I have asked? I have asked to this central x33. Is this clear to everyone? Yes, sir. That is actually the convolution operation, first of all, being done over only one pixel. Which? Central 33. Yes, we all can see. Yes, central pixel. We have seen that how we can find out the color variation. And then I take and apply this pixel over each and every pixel. I will place it over here first, then I will be considering this, then I will place it over here, then I will be considering this, then I will place it over here, and then at that point I will be considering this. And at this and in this way I can ask this question, which is saying that do you have a x derivative, do you have variation in x direction to each and every pixel, by placing it here and striding it in all possible direction. How many directions in which I can stride? One which is in this direction, other one it is in this direction. Why in two directions? Because my image is actually 2D. I'm having a 2D image. Only two directions are there. First in X direction, then in Y direction. So you start from here, apply it here, then apply it here, then apply it here, then apply it here, and then you apply it over here. So in this way, whatever the output that you are going to get, that is the filtered or the the response to this question. Response to this question is actually being saved in another image of same size. So response can actually be R11, R12, R13, and so on. So response can be like this. So you have got an image. So you have got an image like this I, and you have got a response like this R. So you have got an image I and a response R. Is this okay to everyone that we have got an image and we have got a response? Yes. Yes. So once we understand this, I am going to say that you need to write in your own copy, and for that I'm going to give you time as well for 1.5 minutes. What you need to do is that you need to write few question. The way in which I have asked minus one, minus one, minus one, zero, 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 one, one, one. This was trying to ask that do you have this? The question is that do you have a pattern in X direction? I mean, do you have variation in X direction? You need to write similar question for Y direction derivative or the Y direction change one and diagonals, two diagonal. Like I wanted to know that do you have an edge, in how variation in the X direction, variation in this X direction, and variation in the diagonals, two diagonals. So you need to write three kernel, 3 by 3 kernels, two, the way I have shown it over here. Please write in your copy. In 2 minutes I am going to see. Wait. Hello? Yes, I need to go for some 2 3 minutes. Let us see that. Do you all understand that what we want out of this? Yeah, so you can write in the chat box, in called chat box. Oh yes, several persons have written. Oh my God, you all have written it almost correctly and almost not. I mean exactly correct. So you'll understand. Yes, yes, yes. I mean this Vishnu, this filter. Yes, yes, yes. This all these things are fine. Diagonals and current. Yes, this is correct. Okay, so I assume that we all understand this convolution and filtering using such a convolution. So I guess that now we can uh, now we can yes. So this is convolution for you. Let me rephrase it. I will take this filter or kernel, place it over this pixel, then this, and then this responses I am going to get for each and every pixel. We are getting different responses. This is also okay. Now, now we are going to talk about CNN. Yes. So we are almost ready for the CNN. Let us see that. Uh, yes. Now, how the CNN actually works, and we are going to see it for very simple basic classification problem. And what is it? That previously, for every neuron, what it was learning, how can I give weight to each and every pixel? In in convolutional layer, network need to learn a filter like this. Filter is actually a question, and this is actually a 2D question. We need to figure out and understand that what type of 2D question that we are interested in, we are looking for. So let us start with this, that we need to figure out a network that we wanted to make. This is CNN for you. It is going to take a two-dimensional pixel array like this. It's actually an image you all have seen, and given any image like this, it need to figure out whether it's an X or it's a no. Okay, it's an X or it's a no. Okay, so if I show an image like this, it will say X. If I show image like this, it will say O. But it's not very simple like this, because your image can be actually translated or scaled or rotated or weighted. I mean, it may be thicker or thinner, and for all of them your CNN need to say that it's an X, and for all of them it need to say that it's an O. Okay, X or O. We need to decide that whether given image is actually X or it's a no. Now the point is that it's always not going to be that this is always exactly shown the same way, like this neat and clean X. Sometimes it may be rotated, sometimes it may be scaled, sometimes it may be small, big, whatever. So how can I say that these two things are same or different? So naive thing that you can say is that computer is going to see this image like this, in which all these things are high, remaining things are low. Similarly, all these things are high and remaining things are low. Can we say that both of them are equal or not? And if you simply check that the places where these values are same and different, red places, they are different. These red places, we can see that our image, both of, both of these images are having different pixel values. How many? 16 places it is different. And if so many places, if things are different, you can say that they are completely different. But they are not completely different. They are different. uh, they are sorry, so they are different, and the reason is that they are different because there are so many places they are different, but are they really different? This is X and this is also X. So network is going to say, or your simple algorithm by which you are saying that let us match pixel by pixel, matching pixel by pixel is not going to work here, because pixel by pixel 16 places they are different on you, and then you need to say that they are different. But this is also an X and this is also a rotated version of an X. How can we come up with an algorithm which will say that both of them are same. Both of them are same. How can we say this? So now you can see that if I take this and if I take this, both of these things are same. If I take this and if I take this, both of these things are same. This area or the patch is completely same as this patch is also completely same as this patch is same as this. So all these patches are same. The reason is that convnets or convolutional layers are trying to help you to see image in parts and match image in parts. We do not want it to match in a holistic manner, but we wanted to match in such a way so that this region is exactly same as this region, this region is same as this region. So regions are same, and if regions are same, then we will say that images are same, because you can see in these two images all the regions are exactly same. Only there are slightly variation in the place where it is, and that is because of the rotation. And this is the thing that we are looking for, that is there any way which will allow us. So we will say that we require three filters like this: filter 1, filter 2, and filter 3. I will ask this question. What is this question? That, hey Pixel, I want to ask one thing, that do you have a component like this? So I will ask this question to each and everyone. I will ask another question, that, hey Pixel, do you have a image? Do you have a line like this? And, hey Pixel, are you the part of some line like this? If I ask these three questions, question number 1, question number 2, and question number 3 to each and every pixel, I am done, and I can figure out that if we have good amount of pixels which are asking or which are answering positively to this guy, and this guy, then probably we are saying that it's an X. Otherwise, it's not an X and an O. So how it's going to be done is I'm going to show you directly, which is like this. This is one filter and this is one image. I will take this filter, place it over the image, and multiply this value with this value, then this value with this value, then this value and this value, and then 9 multiplications. I keep, I'll keep this all 9 multiplications. I will keep these 9 multiplications over here and then add all of them, and I will get the response or the answer that I have got for this pixel. Okay. So that's the same thing, that I'm just saving these responses of these 9 things. And once I take all these responses of 9 things, I add all of them, which is being shown over here. I add all of them and place what is the response for this, that's actually being placed over here. Response, when I ask this question to this guy, I will get this value. Then I ask the same question to the adjacent guy, maybe over here, then the next guy, then the next guy, then the next guy, and keep on saving my outputs over here. So what we are going to get is that I will have an image, I will have a kernel or a filter. I take this image, apply this kernel over that, and will get a response like this. Is this response is okay? Because what you can see, that all those pixels which are over here, they are giving high responses, others are not giving high responses, and we all understand why. Because that's the question. If you ask a question which is saying that do you have a line like this, then these guys will be giving you high answers. Right now these guys are giving you high answer. Let us see that do we understand this stuff. You can say that yes, you understand or not understand. Yes. Okay. Yes sir, yes sir. Those who understood, please say yes. Okay. So uh, yes, so this is here. Let me see. Yes, yes, I guess that you all can hear, right? Now instead of asking only one question to the image, I ask another question. So I will say this is first of all formally that given image, given a filter, I do this. This is actually convolution. This is the full convolution operation, and I will get a response like this. Then I have question number one, question number two, question number three. I ask three questions. I will get three responses. Response number one, response number two, and response number three. So I have got three responses as well. Now, if I add all of them into one and say that I have got an image, over that I apply these three filters, I'll get three responses, and these three filters are being encapsulated, saved into one. This is actually called as one convolution layer for you. So in this way, you can see that we are having one image and applying a convolution layer over that, and we are getting, multiple responses. How many responses you are going to get? Number of filters are 3, then we will get 3 responses. If we have 128 filters, how many responses we are going to get? Please write in the chat box. If I have 128 filters, then how many responses? 128. Anyone else? If we have 128 filters, then how many responses? Yes. Yes, because it depends the number of layers, number of filters and number of responses. So I take this image, apply number of filters, and I am get the same number of responses. Clear? This is called one conv layer. So in a conv layer, convolution layer, if I say that you need to define one convolution layer, what are the things that you need to tell? You need to tell number of filters. How many filters are there? 3. Okay. And then if there are 3 filters which are being there, then what is the size of each filter? And 3 by 3. So we need to say that there is 3 and there is 3 by 3 such size. So what are the parameters that are required to be initialized for this layer? You need to tell how many filters are there and what is the size of each and every filter. So this is actually that analogy. If you wanted to give into your class, you need to say that same image need to be seen by 3 different specs, 3 different goggles. I am having one goggle, second goggle, third goggle. My first goggle is giving me a very different type of view of this image itself. When I see this image with this goggle, I am getting this view. When I'm seeing this image as this goggle, I'm seeing this view. When I'm seeing this image as this goggle, I'm seeing this view. I'm seeing 3 different type of views, 3 different views that I can see. Multiple views I can see. If I ask 128 questions, I can see 128 different views out of that. Once you have got a feature response like this, over that we apply pooling. Pooling is just to reduce the size of your response. So we will do 2 by 2 pooling, which means that I will take 2 by 2 and take whichever the one which is actually having the maximum value. That is why it is max pooling. So you see that this is maximum that is being coming over here. Then I will take this 2 by 2. Then I will take this 2 by 2. And in the same way I keep on doing and take every time this 2 by 2 and find out which one is the maximum. I'm seeing that this one is the maximum. So you see that once I do this, I will get this value as the maximum. Then I will do this and I will see that this value is the maximum and keep on moving. That is the pooling value. So in this way, suppose that this is 100 and this is also 100. Once you do 2 by 2 pooling, this will become 50 and this will also become 50. So that is max pooling. And whenever I do 2 by 2 pooling, which means that every time I will take these 4 pixels, then these 4 pixels, then these 4 pixels and take the one which is the maximum. They are coming over here. So in this way, you can see that whatever the response that I have got, over that I have applied max pooling. And this is the response or the output or the answers that we have got when we apply different filters over my different image, and then I am not using it directly. If you remember, this is the response, and that's the linear response that we have got. Over that we are going to apply a non-linear operator. What type of non-linear operator we are going to apply? So just to rephrase it, I'll talk about the next operation. But before that, once we do this pooling, we will get out of this big feature, we will get a small or the half width and half size max pooled feature. And since three feature filters were applied, so we will get three reduced size feature, and that is one pooling layer for you, which will take these three things in and the pooled feature out, the small size feature. And finally, the third point is that we apply normalization. Basically, we apply activation function over this feature. So whatever the feature that you have got, over that we can apply sigmoid, ReLU, or any other type of operator. So we have said that it is in convolution neural network, given any image, we are going to see that image using multiple specs, multiple goggles. We are having goggle number one, which is going to talk about that do you have a diagonal edge, do you have a off diagonal edge, do you have a x direction edge, do you have a y direction edge. All different types of filters are being applied over your image, and these are going to be the responses of them. And over that we are not directly using it, we are going to apply some activation function over that. That is your ReLU response, because you understand that non-linearity and the answer of activation we have given in my previous class. So ReLU is actually rectified linear unit, which is a so this is actually very simple, which is being shown like this. You can see what is the meaning. This is 0. So if it is 0 or less, basically negative. If it is negative, I will curtail it to 0. If it is positive, then whatever your value, same is going to be transferred from here and here to here. So if it is 0.7, same thing will come. Minus 0 will come. 0.11, 0.11 will come. Negative, then this will be 0. So that is what you can see, that after applying activation over this, you are going to get these values. And in these values, you see that several become 0 because they were negative. So whatever negative values, they become 0. And that is the non-linearity that is being introduced. Why do we require this? It requires huge amount of other sort of explanation. So we are not going, but yes, we first apply convolution layer, then apply ReLU activations or other activation functions, and then do pooling. Now that is convolutional neural network. The full convolutional neural network can actually be seen like, I have an image. Over this image, I will apply convolutional layers, layer number 1, then we apply ReLU, and then we apply pooling. And then you will get a feature like this. So if I apply 3 filters in this layer, I will apply ReLU over that and then do pooling over that. I am going to get a small size because after pooling my feature size reduced, and I will get 3 outputs like this. So if I apply 128 filters, I am going to get 128 outputs. If I apply 256 filters, I am going to get 256 outputs. Yes. So then we will do deep stacking, which essentially mean that I have got an image and over that I apply conv pool. So I'm doing convolution layers, then pooling layers. So this conv and ReLU, you can assume it as the same thing. I mean, right now in convolution layers, both of these things are actually being merged, which means that first I take a few filters, apply it over the image and apply the ReLU function over that. So this is like conv layer. This is another conv layer. So in your deep stacking, deep neural networks, we apply conv pool, conv pool, conv pool, conv pool, and so on. And at some point of time, after pooling and pooling and pooling multiple times, because pooling is going to reduce the size of my image to half in height and half to width, then we will get a small size feature. Now you remember our old concept that if we got a small size image or the small size feature, now you can open it and flatten it properly, and then you can apply your deep fully connected networks. So this becomes very small. After that we can open it naturally like this. Flattening, you all remember the way I have shown, that's flattening. And this is the feature, input feature, that you have got as an output of your convolution layers. And this is your final last neuron. This neuron is going to see all these things and going to tell that whether, if you have seen X, then what sort of outputs you are expecting over here. And if you see this, then this probability becomes high. So this neuron need to learn that I am going to give you the probability by which this input is going to be belonging to an X, or this input is going to belong to an O. This is a final neuron in the final layer. It's going to do the thing for you. So if I show it in this way, then this can be a fully connected sign of my fully connected network. And then actually you can have, conf pool, and so on. And after that, once your feature becomes small enough, you have got fully connected, and multiple fully connected layers like this. So conf pool, and some multiple fully connected layers that you are actually getting over here. Yes. So so that's actually a fully, deep convolutional neural networks for you. Deep convolutional neural network is this. And how we can actually, so what you are learning over here we are learning few questions. What are those questions? They are being embedded in this 2D filters. And what is the size of each and every filter? 3 by 3. How many filters you can apply over here? As many number of filters that you want. So suppose that in your first layer we have applied 128 filters. And how many such filters? 120. What's the size? 3 by 3. And suppose that here I am applying again filters. How many? Again I am applying 256 filters of 3 by 3 size. And here I am applying same. So I am doing a pooling over here, and that is a 2 by 2 pooling. Okay. The image size is, say, 256 cross 256. This is my conv 1, both of them, conv 1. That's my conv 2, and then pooling. So what is the output dimension after this pooling we are going to get? This is the thing that we are now going to check. Do you all understand what we have done till now? What we have done till now is that is 256 by 256 input dimension. First con, I am applying 3 by 3 filters and 128 such filters. Conv 2, 3 by 3 filters and 256 such filters, and pooling 2 by 2 such filters. And you are applying pooling over that. So that is the thing that we are doing one by one. And let us see that what is going to be the output size, output dimension size. Let us start it from, say, first thing, from here. What do you think? So if I take 256 by 256 and apply 128 filters, then how many outputs you are going to get? 128. And what is the size of each output? Same, 256 by 256, because convolution do not reduce the size. Convolution is not going to reduce the size for you. So out of this, you are going to get 256 cross 256 cross 128. Is this clear? Which is like first response, second response, third response, fourth response. How many such? 128. What is the size of each? 256 cross 256. That is your first output. How many of you actually get this first output? More than 256 possible. Yes. What are they? Yeah, 128 randomly chosen. Yes. So this is being chosen, and the point is that yeah, they are being chosen, but not randomly. Initially, big research groups they used to work on different things, and depending upon whatever the results that they have got, yes, they are the hyperparameters, and these hyperparameters are being there are certain guidelines by which these networks and these hyperparameters are being chosen. Yes, correct. Now the point is that if I have shown you a image like 256 by 256, and in your first convolution if I apply 128 filters, each of size 3 by 3, what do you think is going to be the output size? Are you all agreed with 256 by 256 by 128? Yeah, is that okay or not? Yes, others. No. Yes or no? Okay, let me redraw it. Attendance link is what I don't know, but probably Uma madam can tell. Not sure, sir. Okay, let me tell you. Yes. So over this, when I apply 128 filters, how many outputs you are going to get? 128 outputs you are going to get like this. And each output is going to be of size 256 by 256. So this representation is actually being written as 256 cross 256 cross 128. Is this clear to everyone now? Now let us see. Yes. Others can also say. Sudha madam has said yes. Palak is saying yes. Shashikala is saying yes. Yes. So if we understood this, yes, 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 yes. Then I'm sorry, whatever I have done. Yes. So if we understand this, then the output that we are getting from this is 256 by 256 by 128. First thing, what is going to be the output after this? How many filters I am applying now? 256. Then what is the size of my previous output? Like this, 256 by 256. My output is going to be how many outputs I am going to get? 256. What is the size of each output? 256 by 256. Why? Because till now no pooling has been applied. No pooling has been applied, and the first pooling layer is this layer. No pooling is being applied. If no pooling is being applied, then your feature vector remains to be of the same size. And now when you apply pooling over this, now you all have to tell me that if input dimension is 256 cross 256 cross 256, and then I go into pooling, what is the output dimension I am going to get? Output dimension. You all can tell. And the pooling is of size 2 cross 2. Pooling is 2 cross 2. Let us see. 256 by 256 by 256 is actually the input to my pooling. What is the output? What can be the output? Reduced, correct. 2. Jasila is half correct, not full. Who can correct? 256 by 256 by 256 divided by 2 by 2. It's also half correct. Not in fact half correct. Jasila's thing is half. Yes, Shashikala. Shashikala is correct. And Jasila, can you comment that yes, you understood what was your mistake? because feature dimensions, yes. So so pooling is only going to reduce the size spatially, because 2 by 2 is happening on each and every response. So number of responses is not going to be reduced. So how many number of responses? 256. So it remains 256, but 256 by 256 become 128 by 128. I'm not sure all these guys are BTech, so because they are answering and I was supposed to teach to other group, maybe I started to wrongly interpret them as they wanted to teach to ninth class or 10th class, because I now started to talk about some high level concepts. I'm Do you all understand what I'm trying to say? Other than Jasila, Rini, Yogini, Sudha, Palak and Karuda. Others may comment. Your comments may be harsh. I can understand. I may not be able to deliver a low level lecture. It may be the thing. You can write. Please don't worry about the feedback. I'm okay. Please write that you all understood, or at least get the gist of whatever I was trying to write. You please write. It may be that I may not be able to deliver the things that you were looking for. Yes, I've got Shinju Daniel. Saugita Day saying yes, now new persons are also getting and saying that yes, we are getting. Asha Sharma, Shashikala, Sugata, you all are getting, then I am happy. Every batch of students come with a higher intelligence. Yes, okay, getting. Oh, then it is good, because if you all are able to get this stuff, at least the basics, because they are really basic, and if you are able to get the gist of this stuff, then we are fine, because that was the motivation behind this lecture. Yes. So we are about to finish. I'm just to my final lecture stages. So it's like pooling we are doing, and then we apply some conven also. Now you can understand that after this pooling, what is going to be the dimensions of my input to these fully connected. And if I tell you in this fully connected we are having 100 neurons, and if we are having 20 neurons over there, and last we are having only 2 neurons. Why? Because there are only 2 classes. And then full architecture is known to you. This full deep learning neural network architecture is known, you understood. And from given this image, you can compute that what is going to be the output dimensionality, as well as what is going to be these these values. Once you have got these values, you find out that what is the loss. So suppose that if I have shown X, and my final neuron is saying with 0.9 probability it is X, zero point 0.5 probability it is O, but the right answer was it has to be 1. So X has to be the right answer. So for right answer it was X is 1 and 0 is O is 0, but my actual answer is this. So I find out how what is my error. This is my error, because it has to be 1, this subtracted to this and this subtracted to this. So once I got this is my error, I add this whole error and find out this value, and then say that okay, this is my loss. I need to back propagate somehow into my network, so as to change these questions, these available parameters of fully connected as well as convolutional filters, so that this error become as less as possible. That is actually the back propagation algorithm. We are not covering, we are just giving you the gist of that. And back propagation is a gradient based algorithm, gradient and derivative based algorithm. And suppose that this is the surface over which you are trying to drive, and wanted to go to the minima of something, because you wanted to minimize your error or your loss. So Newton said that if you are at this place, you find out your derivative is in this direction and you need to move in the other direction. That is the gradient descent in 2 lines. If you are here, you just see that what is the direction of your derivative. Your direction of your derivative is in this direction. You need to move in the opposite direction. That is the gradient. If you keep on going like this in the opposite direction of your gradient, because here if you are here, then your derivative direction is this and you need to move in the direction like this. So from here you first go there and then come here, and slowly you can converge in the minimum value. Yeah, so we are done with this. What are the hyperparameters or the knobs that you need to somehow fix initially for a CNN based networks? Are for convolution, the number of filters that you wanted to apply and each size of each filter. So if you wanted to apply 128 filters, and what is the size of these things? Pooling is going to tell you that what's 2 by 2 pooling or 4 by 4 pooling. Mostly it is being 2 by 2, and 2 is stride. Stride means that how fast you wanted to go. First you apply here, then you apply here, then you apply here. So how fast you are going, that is actually the stride. In the case of fully connected network, we are only interested to know that number of neurons, that how many, 100 or 1000 or 1000 or 10,000. How many neurons are there in one fully connected layer? So these are the parameters that we need to somehow manage. Yes, up to this I was planning to cover. We are done with this. You can write your comments and your feedback and other questions in which you are interested. So do we repeat? Yes, you can repeat this process. Yes. And that is why first you apply convolution, then pooling, then convolution, then pooling. The same thing is being applied and being repeated multiple times. Multiple times such things are being repeated. Yes, we are done. You can write your feedback, your questions, your comments, any other thing that you wanted to say. I am done. Clear. Okay, good. I request all of you to at least please write, any comments that you have, any feedback that you wanted to give. All of you, at least there are 100. I request that please write something informative. Thank you. Yes. Thank you. Thank you, Manoranjan. Harvinder Singh. Yes. Where is the labeling happen? Yes. So for that we have training data, and for training data we know that whether it is an X or O. That is why it's a supervised learning. Concept cleared, good, informative. Thank you. Well explained, understood. Most of the concepts are clear. Thank you. It's a very nice and short time. Yes, it was very short time. I wanted to give some complex concepts. So, but anyways, it was very fast. Yes, well explained. You changed teaching style to yes, yes. That's perfectly correct. I was teaching in a very different way, and that's why I said that, because Rini and others which were there, they were trying to tell me what you, the way in which you are thinking. I started to change the style and started to talk the way in which probably you may be interested. Yes, so that is very important. And when somebody is teaching, you keep on asking questions and guide that guy, because he knows something. Teaching is completely different than knowing. Very informative. Yes.
I could add one point.
Yes, ma'am.
Actually, all are from school teachers, right? So they were so much worried about day one, how to deliver this content to their school kids.
Yes.
So it is actually we have to train these participants so that they have to deliver. And for class 10th, they have the syllabus on artificial intelligence, it seems, and they have
Yes.
shared the content of the artificial intelligence with me. And so these people are so worried. How do we deliver this complex things to their to their school kids? And the moment they were keep on asking the same question, but you have given a clear idea how to deliver to the school kids. It was so awesome. So I
Yeah.
was really impressed, because
Yeah.
the moment you are changing, because you have come in your mind delivering this kind of thing, and
Yes.
you have understood the audience, and then you have suddenly changed your way of teaching the style. That's what the audience feedback.
Audience feedback.
I could
Yes.
see that.
Correct.
So since you understood the audience in a short span of time, and then you wanted to know what kind of information they may require, so you have explained that neural network in a very short span of time, so that it was so awesome. So
Yes.
I myself impressed so much. So I
Yes.
think participants also feel happy about it, because all the complex topics are very complex, and how do we deliver to the school kids if their teachers are so much worried, and then they have to incorporate all this different kind of teaching style that they do with them. That is grateful.
Yes.
So I,
Correct.
yeah, I can ask some teachers to unmute and then say your feedback. If you got enough information, how do you deliver to your school kids? Is it fine? You can share your thoughts with Dr. Aditya Nigam.
Yes, you can share if you want, then you can speak. And yes, I completely forget initially that what is the audience. Actually, I forget, and then somebody asked, and then I actually realized that okay, I was teaching, something else.
No, no,
Yes,
that
that.
instantaneously, no, switching from one mode to another mode, it's very difficult for the speaker.
Yes,
Sometimes
yes,
we want to deliver what we want to deliver,
yes,
forgetting
yes,
about the audience. But you have completely switched from one mode to another mode and then started delivering the what the audience want. That was really appreciable. This is my observation.
yes, correct.
So yeah, anybody teachers wants to speak a few words with Dr. Aditya Nigam, you can unmute and then speak. Sir wants more input, because if we want to organize next workshop, we will take your feedback, valuable feedback to incorporate what is expected from you.
Thank you, sir. I'm Jessica.
Morning.
I'm joining from United Arab Emirates. Actually, this well done, sir. This neural network was the little bit difficult when I was trying to learn myself, especially the convolutional neural network. Now all the doubts are cleared, because when we go to internet, we will get all the codes. Codes are available freely, but we don't understand what is max pooling, 2D, conv 2D, like that. But regression and all, it was a bit more easy. We could understand. But when we go to the convolution neural network, but even I felt much more difficulty. But you could deliver it very well. I understood very well. And but for other teachers, I am the head of the Department of Computer Science in my school. I'm just guiding all other teachers. Then I am telling that actually starting from 8th standard is clearly given in the syllabus. Only we have to give some interest for the students. When 9th standard comes, little bit higher level, just we are giving the basics of Python, and here we can give the library, and using the library we can give the coding so that they can understand the library and the coding. When we go to 10th standard and a little more higher level, we can go deep into the library and we can explain what this library is doing. Now next year, 11th and 12th, they will start. Actually, now the first time in grade 10. So I don't think much difficult, because in the content itself, in the syllabus for teachers material, clearly it's given what to teach, how to teach. So I don't think that much. No need to give advanced comprehension from grade 8 and 9. So rest all is fine. Teachers should know all the concepts. That's the thing. Then only we can go to the lower level and teach grade 8 and grade 9. So I think your workshop is given that thing very well. And even I am look forward for little more advanced concept if you give one more workshop. Thank you, ma'am. Thank you, Maharani, ma'am, and Aditya, sir.
Okay.
Thank you.
Sure, ma'am, we will take your valuable feedback. My thing is, for in addition with that, we have to do digital image processing course. If possible, I will arrange with this a set of experts. Digital image processing course will actually require, because we straight away come to AI and then start working on deep learning will be a bit difficult without getting the digital image processing concepts. If possible, all I request you, if you get an opportunity through AICTE sponsored workshop, you get attended digital image processing, computer vision. So this will help you to understand about recent trends in AI, ma'am. And one more
Okay, thank
speaker, yes, sir. One more sir wish to talk, Mithilesh Kumar. Can you speak few
Good,
words, sir?
good afternoon. Good afternoon, everybody.
Yes, good afternoon, sir.
Uh, Ma'am, first of all, I take this opportunity to thank AICTE and IIT, Triple IT DM Kanchipuram, and all the
Yes.
speakers for the wonderful lectures and information. Madam, I'm from Kendriya Vidyalaya institution. At the school level, ma'am, I just want to add at school level, actually the intelligence level of the students is, I mean, the gap is very big. You get some who are not so good, some who are very, very good. And to be teaching at the BTech level or rather engineering level, the level plane is, I mean, the playing field is almost equal. So with this session, at least the students first want to know actually what is, why are we teaching it? I mean, AI, everybody knows AI hota hai, but they first want to know ki, uh, not the specifics, but the generalization. Ki what is, what exactly are we trying to do? So as Aditya Nigam sir first started, ki actually we are trying to. He said with different examples that we have a sentence and we can construct a picture, and that is the that will arise the interest level of the students. Then
Hmm.
we can go into, okay, we can go into regression and naive Bayes and so on. Uh, that I think where we should start.
Yes.
Actually, what is being done in the field, what is the end result, then the curiosity level of the children will come up. Okay, now we should know why or how we should go about it. So I thank you again, everybody, for such information. Thank you, madam.
Thank you, sir. Thank you, sir. Well said. So it is all about how do we train so that you can go back and teach your kids. That is much important for us, and that's the motivation of this AICT program. Anybody would like to add on? One more speaker or one more audience? Hello, one more participants. If you could hear feedback, it will be good. You can unmute and then speak your because your feedback is so valuable for us.
Hmm.
So just to share your thoughts, nothing to do with this. Share your thoughts. How do we improve further?
Everything was well organized, ma'am. Uh,
And introduce yourself and then give your
I'm
feedback.
Swati from Sangamitra School, and I'm in the computer faculty. The organization was very good by Mr. Subin and you. You all did a good job. And my only thing is a little bit slow. The previous ones, I felt they went a little bit fast. So a little bit slower. When you do the next time, at least the audience is very diverse. Not everybody is technically sound. So it's a little bit slower, and that's what I would like. But still, it was a very good session. Thank you.
Yeah, okay, ma'am. Okay, ma'am. We will take your suggestions and then we'll incorporate for the next time for sure. So with this, I thank speaker Aditya Nigam. Sir, you would like to give any suggestions
Yes,
for the teachers because teachers they have to go back and then teach to their school kids.
yes.
Yeah, your
So my
comments is valuable. Yeah.
Yeah, so my comments are yes, AI is important. Somebody already have said that yes, we require to first of all show them multiple exciting applications. These applications are available in the form of YouTube videos which are publicly available by the researchers who have made these stuff. You show them that neural transfer is happening, style transfer is happening, and then somebody was writing probability linear algebra. Yes, these things are the base and the bare backbones, but these 8th or ninth guys, they may not be aware of this. But on internet also, I mean, few links are available which are actually trying to somehow abstract most of the things and try to talk about convolution without letting anyone to understand about the matrix and the probabilities. So we need to somehow abstract the inherent computation and then give them the bare minimum computation which is required. Other thing is that if you feel that anyways, yes, I was slow because diversity was, I mean, the class was very heterogeneous, and initially I was teaching something else and then I have to change that thing. But my suggestion is that those who are interested to know more about it, you just need to go on YouTube, because here I used to teach this deep learning and applications to all of my students whenever I am teaching in UG BTech level course, and everything I have recorded and uploaded it on YouTube. So on YouTube, you just need to write deep learning at IIT Mandi. You will get my channel, not from my name. Aditya Nigam, you will not get from, maybe from Aditya Nigam, or you just write deep learning at IIT Mandi. You are going to get, at least 40 to 50 hours lecture material in which, starting from the basics of, machine learning, I have covered the extreme, latest concepts. So you just see that how many initial things are required for you, few lectures which are available that can be used to start, at least for the teachers, because first thing is that teachers need to understand, and then they can dilute it according to their own need. So but teachers are also not like, they are the high end researchers. They require things also to be diluted first, so that they can acquire, and then once they understand, they started to deliver it to the students. So for teachers, definitely I am sure that a few places which are available, they used to talk about deep learning in a very bare minimum mathematical stuff. And also on my YouTube channel, you can see certain things, at least initially 3 4 lectures, one at least 1 or 2 lectures of CNN, 1 or 2 lectures of RNN. Whenever I used to teach RNN, that's a recurrent neural network, I started to give the example of Virat Kohli, start from that example. So few examples that need to be somehow chalked off, which are related to the physical environment of the student, and probably from that they will be able to understand the visualization and the concepts which are going to be built over all of them. But definitely it will take time. It's a tough job, I understand. I'm with these comments, I'm done.
Okay, okay, sir. Well said. These comments will be valuable for them also. Actually, syllabus of the AI was not shared with us. So we framed according to the engineering students. So later on, yesterday only, I received the syllabus from the CBSE teachers. So if I would have been got well before, then I would have arranged in that fashion. But although we have covered 80% of the syllabus, uh, it is not too much. We have, uh, we have addressed almost 80% of the content. I could see that. So with this, I thank Dr. Aditya Nigam for the end of this
Somebody has raised a hand. Somebody has raised a hand.
raising hand. Okay.
The few persons are raising the hand. Can you please allow them?
How do I do? Yeah, I am allowing. They can unmute and
Yeah,
speak.
so now you can.
Uh, Uma ma'am, I am Sonu Locha from DAV Public School, Gurugram,
Yes, ma'am, go.
and I like to add on that as I am teaching AI to class 9th and 10th,
Yes, ma'am.
so we have covered 100% syllabus. As per the CBSE guidelines, you have covered 100% syllabus in
Oh,
your
okay.
workshop.
Okay.
Rather,
Thank you.
you have taken us through lot of practical things. Like in future, if our students will take AI in 11th and 12th, and they like to make projects, then the
Okay.
sessions taken by your college, your university, sorry, your institute, will be really helpful
Okay,
for
ma'am.
us.
Fine,
Uh,
ma'am. Thank you so much. Actually, I did not receive the syllabus well before. So if I would have I would have seen this, then I would have make even more exactly what I want to cover, I would have taken my enough effort. But it's fine. So we will do once again. If you people are much interested, I can arrange more talks on deep learning and then AI, ma'am.
And we'll appreciate Mr. Nigam will be involved because we are really impressed the way he taught us.
Yes.
Seriously, sir, you made the complicated topic easy.
Oh yes, thank you very much.
Okay. Thank you, ma'am. Thank you for your valuable suggestions. Is there anybody would like to talk, ma'am? Shall
One
we?
was one. There was
Ah,
one more. There
one
was
more.
one more. Yeah, there was
Who
one
is that?
more.
Ma'am, you can unmute and then speak. I'm allowing whoever wants to. It's our pleasure to have.
Somebody
Ma'am,
was.
the hand.
Who was that? Let me see. That is Lavanya. Lavanya is there.
Lavanya, ma'am.
Lavanya madam is there.
Rajeshwari, ma'am.
Hello.
Yes.
Yes.
Yeah, thank you so much, sir.
Ma'am,
Thank you,
ma'am.
ma'am.
Introduce yourself and then.
Yeah, I'm Rajeshwari, head of the department in JSS Private School in Dubai. It was a wonderful session and
Goodbye.
as a school teachers, actually we need more things actually. And last year only AI got introduced. It's a really very useful session and very informative. It's really enjoyed.
Thank you, ma'am.
Thank you.
Okay. Lavanya, ma'am, who has raised the hand, would you like to add more? I will have a look, definitely, your curriculum. Lavanya, ma'am, who has raised the hand, would you like to add some more, ma'am?
Mhm.
I think,
Yeah, I guess that we are done. Yes.
okay. Okay, with this, today is the last day, sir. With your talk, there is no other theory session. So we have left only the practice session, which is going to do in the afternoon. It was very wonderful session. Rather than teaching the technical concepts, you have thought how to take this level of course to the kids was very wonderful. So I thank you. I thank you, sir, for joining the session and then share your valuable thoughts for the introducing new and complex topics to the novice user. I mean, not your novice uh, people is very difficult. I can see that. So I thank you so much for joining us and then make this workshop so successful.
Okay.
Okay,
Thank you,
sir.
ma'am.
Thank you.
Thank you,
Thank
ma'am.
you. Okay.
Thank you.
So you can share your email ID in the chat box if if they want to talk. You can
Okay.
type your email ID in the chat. Sir. Thank you, Aditya Nigam. Dr. Aditya Nigam. 1 second. Yeah.
That is aditya@itmandi.ac.in.
Ma'am, the next session timing.
Next session we could join at 2, as we have informed earlier. Sir is typing us. Thank you, sir. Thank you so much.
Okay. Thank you.
Thank you. Sir, please kindly share your materials so that we will share to the participants. So let us join at 2 o'clock for the practice session.
The old link, right, ma'am?
Yes, old link.
Old links, okay.
You could please share those links in the WhatsApp again.
Okay.